Hello and welcome. In this lecture, I will be showing you how to debug JavaScript in Chrome Developer Tools. There are several steps we'll need to follow to create a basic workflow for debugging JavaScript in Chrome Developer Tools. The steps will show you how to debug one specific issue, but the general workflow you will learn is going to be helpful for debugging all types of JavaScript bugs. Using the console screen within the debug can catch some common errors, but using this workflow we're going to use now will give you a more wider perspective and will give you a proper workflow to catch the errors and fix them. So let's take a look at the steps, and the steps will be covered in separate videos. The first step here is to reproduce the bug. Okay, so we need to be able to reproduce the error or the second step is to pause the code using a breakpoint. So we need to be able to set a breakpoint in the code so that when the code runs up to a certain point, it takes a break and pauses. So we're going to set up a couple of breakpoints. We're going to set up the first one here. Then the next step is to step through the code. The reason being is that sometimes when the script executes, it may execute in the wrong order. So stepping through the code enables you to walk through your code's execution one line at a time and figure out exactly where it's executing in a different order. The next step is to set another breakpoint. Next, we will check the variable values, make sure everything is okay. Finally, we'll apply a fix to the bug. This introductory lecture will include some resources. This is the directory that contains some files that we are going to troubleshoot with the JavaScript. So this is just a simple game that contains a CSS file, JavaScript, and a HTML file. So if I run it, this is what it's a basic addition game. So we're going to try and troubleshoot it. So these files will be available for you to download in this introductory lecture. What I suggest you do, download all the three files, create a directory like I've done here, and just call it anything you like, and make sure all the three files are contained in that directory. So that's it. We'll be using that for the direction of the debugging with JavaScript. So that's it for this lecture. Thanks for watching, and bye for now. Hello and welcome. Our goal in this video here is to try and reproduce the bug. This is always the first step in debugging, to reproduce the bug. Basically what that means is to find series of actions that consistently causes the bug to appear. So we need to perform various actions that will make the bug appear. So we're going to open up the program. So open up the directory that says addition game, if you've named yours that way, and click on the index.html file. So what I need you to do, where it says number 1, I need you to enter a number. So enter a number 7, and in the number 2 enter a number 4 and click add number 1 and number 2. If you notice, you get 74. If it's an addition, it should give you 11 and not 74. So this is clearly a bug in the program. So we need to find a way to fix that. So our goal in this video was to try and reproduce the bug. So we have reproduced it. We've determined that there is definitely a bug. In the next video, we're going to move on to step 2. We're going to set a breakpoint and pause the code while the code is running. So thanks for watching. See you in part 2. Excuse me, I meant to say see you in step 2 when we'll be setting up a breakpoint, not part 2, step 2. Hello and welcome to step 2. In this step, we will pause the code with a breakpoint. The Chrome Developer Tools allows you to pause your code in the middle of its execution and examine the values of all the variables at that moment in time. The tool that will enable you to pause your code is called a breakpoint. So open up the addition game. If you are on a Mac, you can press Command, Option and I to access the developer tools. If you're on a window, you can hit Control, Shift and I, or just hit the F12 key and that will open up the developer tool. Once you're in the developer tools, make sure you've got the sources tab. Okay, so you've got elements, console, make sure you've got the sources tab, click, make sure that panel is open. And then on the right here, you see a list of menus. There is one that's called Event Listener Breakpoints. Click on that to expand. And if I scroll down, you see different event listeners. There should be one there for the mouse. So click to expand that. Okay, and you should see all these are events that you can perform on a mouse. So the event we are going to click on is the click one. So make sure you've got that checked. We're going to set the breakpoint using the click event. So what we're going to do inside the program here, up here, we're going to enter 2 numbers again. So enter any number you like. It doesn't have to be the same number as me. I'm going to enter 7 and I'm going to enter 4, but feel free to enter any number you want. Now I'm going to click on the button, which represents a click event. So I'm going to click on add number 1 and 2. By doing that, I've activated the click event. So you can see what's happening here. What's happening here is that because we checked the click checkbox, okay, we've set up an event based breakpoint on all click events. So when any node is clicked and that node has a click handler, the developer tools automatically pauses on the first line of that code's click handler. As you can see here, the code has paused because that is the first click handler event. This is just one of many types of breakpoints that the Chrome Developer Tools offers. So what breakpoints you should use depends on what type of issues you are debugging. So in this step 2, we have successfully triggered a breakpoint. In the next video, which is going to be step 3, we are going to step through the code. Thanks for watching. Bye for now. Hello and welcome to step 3. In step 3, we are going to be stepping through the code. So this is where we left off in step 2. You can see it says paused in debugger. So in step 2, we set up a breakpoint which paused the code during execution. One of the common causes of bugs is when a script executes in the wrong order. So stepping through your code enables you to walk through your code's execution one line at a time, and figure out exactly where it's executing in a different order than the order you expected. So let's check this out. So here within the source panel here, this here is the entire JavaScript for this project, the actual JavaScript that controls this game. You can see it inside this section here. You can see the code is paused there on line 1. So to step through the code, on the far right here, if you look at these tabs here, there's one that says step into the next function call. Click on that, and when you click on that, it jumps to the second line of the code. So it's pausing at each line of the code. So what we've just done now, we've stepped through the execution of the on-click function or event, which is this one here. We're stepping through that function, and we're doing that one line at a time. The next thing we're going to do is step over the next function call. So on the far right here, if you look at this tab here, it says step over next function call. So click on that. You see that jumps from there. So that's the next function call it has jumped to. So what we've actually done here, we have skipped a few lines here, okay, by using the command that says step over the next function call, this command here. So what that's done is stepped over the next function call. So where the function call was at line number 2, okay, so by executing the step next over the next function call, by executing this command, what that has done, it has skipped that. So the DevTools has skipped a few lines of code. This is because the inputs are empty. This input here, there's no input on line 2. That is because it's empty. That's why I've stepped over that function call. Because if the inputs are empty, it evaluates to false. So the if statement block of the code will not execute anyway, because it evaluates to false, because there's no value to evaluate. That's why we skipped over that. So that's the basic idea why you step over a code. So when you're stepping through a code, basically, you know those lines of code, you're not going to get any benefits from it because there's no value to evaluate. That's why we step through it. If you look at the code now in the add.js here, you can see that the bug is probably somewhere in the update label. So this is the update label function. So you can see that the bug is somewhere within that function. So rather than stepping through every line of code, you can use another type of breakpoint to pause the code closer to the location of the bug. We will do that in the next lecture, which is going to be step 4, where we will set another breakpoint. So see you in step 4. Thanks for watching. Bye for now. Hello and welcome to step 4. In step 4, we are going to set up another breakpoint. As you can see, we are still paused in the debugger. We are going to set up a line of code breakpoint. These are the most common type of breakpoint, especially when you've got a specific line of code that you want to pause on. You use a line of code breakpoint. So let's try this out. So at the moment we are on the update label function, and if we scroll down here on line 19, this is where I want the code to pause when it gets here, because I think this is the area where the error is happening. This is where the bug is. So what you do, just click where it says line number 19, click on it, just one click. And what happens, the developer tools puts a blue icon. You can see it's turned blue. This means that there is a line of code breakpoint on this line, which is line number 19. The Chrome developer tools always will pause before this line of code is executed. So it will execute the code. When it gets to this line of code, it will pause. So what we have to do, we need to click on the resume script execution, this button here that says resume script execution. If we click on that, the script will continue executing until it reaches the line of code where this breakpoint has been placed. So click on that and we can see the code will execute until it gets there. So you can see these are you see the values we put in. It has executed. It says 7 for sum 74. You can see here it's executed. Okay, I don't know if you spotted something here, but you can see here looks like the value of the sum has been evaluated as a string, that is as a text. So a text usually has quotes around them. So you can see there's quotes surrounding this value, and there's quotes everywhere surrounding the values, which means the sum values have been treated as a text, hence is not evaluating the addition properly, rather is treating the inputs as a text. So this is a clue here, because the values are now enclosed in quotes, and when you enclose values in quotes, they've been treated as strings or text. So in the next step, we are going to have a look at the values of the variables. So thanks for watching. Bye for now. Hello and welcome to step 5. In step 5, we are going to check variable values. Another common causes of bugs is when variables or function produces a different value than the one you expected. So many developers tend to use console.log to see how the value changes over time. But console.log can be a bit tedious and sometimes ineffective for two reasons. The first is that you may need to manually edit your code with lots of calls to console.log. Secondly, you may not know exactly which variable is related to the bug, so you may need to log out many variables. One developer tools which is an alternative to using the console.log is the watch expressions. So you use the watch expressions to monitor the value of the variables over time. As the name implies, the watch expressions basically they're not just limited to variables. So you can store any valid JavaScript expression in a watch expression. So let's see how that works. Within the sources panel of the Chrome developer tools, there is a watch option. If you look on the far right here, it says watch. Okay, the section can expand. If you click on that expand, you can see here it says no watch expressions at the moment. So we are going to add an expression. So by clicking on the plus sign, okay, and what we need to do, we need to type in an expression. So I'm going to type in type of sum. Okay, once you've done that, press enter. So we now have an expression it's going to watch for. You can see on the right here it's called string. So the string here is the value of the watch expression. So the watch here has given us a clue in that the value of string. So basically it is confirmed what we suspected by the output here of the values. So it says that the suspected sum is being evaluated as a string when it should have been a number. So this is the cause of the bug for our addition game. Another thing we can do, we can use the console to evaluate arbitrary JavaScript statements. Okay, so developers commonly use the console to overwrite the variables values when debugging, so they can just overwrite it during debugging. So in our case, the console can help us test out the potential fixes for the bug we have just discovered. So what we're going to do, we're going to open up the console drawer. So click on the console tab here, and while within here, click on show console drawer. Okay, so what that means, when we go back into our sources, we'll have the console panel here. Okay, so even though our code is still paused, we can access the console from here. So within the console, we're going to type in a command. So type in pa parse int in lowercase, yeah, and then in parentheses type in add and 1, okay, and then space plus, and then type in the same word again, parse int in parentheses add and 2, and then close the parentheses. Once you've done that, press enter, and you can see it's evaluated to 11. So the correct number 7 plus 11 should 7 plus 4. First number entered was 7, second number was 4. That should evaluate to 11. So this is the correct result I expected to have been produced when I clicked on the add number 1 and number 2 here, this button. So from the console drawer, we have proved the correct result for the addition game. So what we're now going to do, now that we know the fix, in step 6, we are going to apply the fix. We already know that it's evaluating as a string. That's why it's giving out the wrong information. So we are going to fix that in step number 6. So see you in step number 6. Thanks for watching, and bye for now. Hello and welcome to step 6. In this step, we are going to apply a fix for our bug. In our previous step, which was step 5, we identified a potential fix for the bug. So what's left to do now is to try the fix by editing the code and rerunning the application. And this was what we did in step 5 to test out the fix. So if we look on line 18 here of the script, this is the variable that was defined. Okay, variable is sum, and if we've set it to add end 1 plus add end 2, and that has produced a string result, as we can see here. So it's giving us a string. So what I've done here in the console, I've used the parse int function. What that does, it parses a string and returns an integer. So it does the conversion into a number. Hence, we've got the correct value here. So what we need to do now is implement that in the code so that it is fixed. So the first thing I'm going to try and do is fix it from within the developer tools and run that. If everything works, then I'll implement it in the original source code of the JavaScript file. So on line 18, where we've defined the variables, what we're just going to do here, we're going to set it where it's got equals to. We're going to wrap the variables around the value of the variable. We're going to wrap it around this here. Okay, so what I'm just going to do is type in BAL parse, and then in parentheses I wrap that first value around it, and then we do plus, and here I come here and do parse int and wrap that also around parentheses. I put parentheses there and wrap that around there. So to save that within the debug environment, if you are on a Mac, you press Command S. If you are on a Windows or a Linux, you press Control and S to save. So I'm going to press Control and S because I'm on a Windows. So that has now been saved. You can see that the background of the code changes color to indicate that the script has been changed within the developer tools. So what we need to do now is deactivate the breakpoints. Okay, so the first thing we need to do is come here to the right, this button here, we click on that, and that deactivates the breakpoint. It tells you the debugger is still paused. So once we've deactivated the breakpoint, it changes the blue to indicate that it is active. Okay, this here has changed to blue, which means it is now active. Okay, previously we had to press on it to deactivate it. So while this is set in the developer tools, the developer tools ignores any breakpoints you've set because this is now active, so it will ignore any breakpoint I've set. So what I need to do now is resume the execution of the script by pressing this button here. It will remove that pause and the script will continue to execute. If you notice, I've got a little error here because I have not done the parse in properly here. So I just need to do int, and that should fix the problem. Do Control S again. That should save it. When you are fixing bugs in a code, it's best to do it on the source file, the original code that serves the page in the browser. Because if you do the changes only within the developer tools, the changes only apply to the developer tools. So when you exit the developer tools, it may not be saved if you've not set up persistent workspace. So I'm here in the actual code itself, and I have made the change here on line 18. So where I've declared the variable sum, I've now added the parse int method, which will convert the string into a number and output a number. Okay, so this is a parse int 1. We'll add this first number, and then it will convert the second number as well, and it will output a number. So it converts the strings into a number. So I've implemented it here. I've applied the fix on line 18. I'm going to save that. I'm going to open up the page again. I'll go here and run it, and we try and do some maths now. Hopefully everything should work out. So I'm going to do 8 plus 4. So I expect the result of 12. You can see it's working. I do another one. So I do 50 plus 50. That should give me 100. So we've got everything working. I'll just check one more number, do 65 plus 15. Okay, excellent. So we've got it working. It's now converting the strings into integers or numbers. So we can open this up in the developer tools just to make sure there are no errors. So this is the developer tools. We can see here, this is the line we change on line 18 here. So it's okay there as well. If we click on the console, just make sure that there are no errors. See, no errors listed in the console. So we have fixed the bug and everything is working okay. So that's some basic steps to how you fix a bug in a JavaScript application or code. Many thanks. I hope the lecture series on fixing JavaScript bug using the Chrome developer tools, I hope it will come in useful. Thanks for watching and bye for now.